This conference will now be recorded.
So can anyone explain what is this case study? Already we have discussed. So can anyone take initiative? I don't want single word answer or single line answer. I want everyone to answer with respect to entire business case, business objective, not just single line or single sentence. So today we are going to complete your hypothesis testing so that we can start your tomorrow onwards correlation, and then we can start on building your first prediction model, first machine learning algorithm we can try.
Yeah, Yogesh.
Yes. While talking, please.
Yeah, CPG
mute
company,
your,
they want to
yes.
launch a new product, and based on
Yes.
the sales team's input, they say that don't launch the product because the adults will not purchase the product, and only the children will purchase this product.
Okay.
So we need to check the confidence level that whether to launch this product or not.
Yes. So it is simple. So explain me in 2 sentences. It's fine, well and good. But I'm just going to give a brief business objective of this particular case study.
Hello.
Yeah. Yes. Who is this?
Bharat.
Yes, Bharat. I'm going to explain you once again. Okay. So this is a CPG company. CPG stands for Consumer Packaged Goods. CPG company launches a new product and also plans to launch a new sales incentive program for their sales team. They are launching a product, and for sales executives, if they sell this product, you want to launch a incentive program for them. But one of our sales executives already felt that if you are promoting sales incentive for this particular product, we are not in this particular product, adults will not purchase more products. Adults will not purchase more products, and children will purchase more product. So your sales executive already told that please don't launch incentive program because we cannot promote it for adults. We cannot promote it for adults. So but your manager, for example, your marketing manager will not agree with respect to the statement. So he gives you some historical data, like previously they might have launched some similar product. Based on that historical product data, you need to perform 2 proportion test, and you should prove that whatever the sales executives are telling with respect to 95%, your sales executives are correct or wrong. So based on the data, determine whether there is a confidence level at 95% to support the plan. That is what the case study is all about. Now, so first step, we need to write your. So when do we go for 2 proportion test? When do you go for 2 proportion test? First question.
Two discrete and
if input is a 2 discrete values and output is a discrete.
Okay. Yes, your output is discrete. Both x and y should be discrete, and you should have y is equal to x1 plus x2. This is also discrete.
Okay.
This is also discrete. This is also discrete. Yes.
Sorry, just got confused again. Output means what?
Output means what?
Once?
Output means.
I understand what is output. What is the outcome of this anything? Yeah, it is out. But in terminology, was like a bit confused. You said
Launch,
output is discrete.
launch or not launch?
No, I'll come to that point. So next question is, after identifying your two proportion test, when do you go for two proportion test is x1 plus x2? By seeing this statement, you should understand what is your output and input. You should tell me that what is your output, what is your input in this data set. That was my next question. So based on this, tell me what is your output first and what is your inputs.
The
Input is
input is adults and child.
Yes, inputs are nothing but your adults and children's, correct? Because both are
Uh,
discrete in nature. What about your,
the
Output is purchase.
yes,
the
output is
product
purchased or
launch or not.
not? Yes, it is not
Physics
launch or
product.
not launch. It is purchased or not purchased. Whether a customer is
Okay.
going to purchase or not purchase. Means customer here is adults are purchasing or not purchasing, children's is purchasing or not purchasing. Okay,
Got it. Thank you.
please be on mute. Please be on mute. So now you came to know what is X, what is Y. So X is adults X1 plus X2 is nothing but your children's. So Y is nothing but purchased or not purchased. So this is your input output. So here, as this is discrete in nature, you should write your null hypothesis and alternate hypothesis. Can somebody tell me what is null hypothesis and alternate hypothesis for this case study?
null high fly. Null high
What?
fly.
No, that is, see, that is just a code to remember you how to decide. P high null fly, that is your quote. I'm asking you what is your null hypothesis for this case study. P high null fly,
Null fly.
The
P
purchase
low
of
null fly.
the
Yes,
purchase of
adults
adults and children's are equal.
equal to. So adults purchase is equal to children's purchase, or that is your null hypothesis. So adults purchase is not equal to children's purchase is nothing but your alternate type. Write down this step. So null hypothesis, see whatever I'm writing it on this, like your X and Y, please write down this. X is your adults and children's. Y is nothing but your purchase or not purchase. This is your output. And here it is null hypothesis is your adults purchase is equal to children's purchase. This is your null hypothesis. And alternate hypothesis is adults purchase is not equal to children's purchase. This is your alternate hypothesis. So if I'm giving you 1 to 2 minutes of time, you should write down this. You should write down these steps. Now let me go to your R Studio and let me open the data sets. Let me open the data set. So after this chi-square test and proof proportion test, I'm going to show you one more topic today, that is called as the R Markdown. It is not a special topic, but it is very good for your documentation part. You can learn this thing. So hypothesis testing. This is your CPG. Okay, sorry, there's something else. Hypothesis testing. Am I not audible?
Yeah, audible.
Bhupendra, I'm audible for everyone. I'm going to put it as CPG. Okay. Here I'm going to read an Excel file, which is from my local system. I'm choosing that Excel file to be stored in a variable called as CPG. I'm going to execute this particular this thing, but as it is Excel file, I should use a package called as read Excel. A package called as read Excel. So I'm going to run this. It will open a window, pop-up window. It will try to open a pop-up window. So once it opens, you need to choose your path. See, it is at the back end. So I need to choose my file. That is nothing but my Excel file. This is my file. I'm going to choose this, and I'm going to store it in a variable called as CPG. Your CPG is having how many records? Just see this. It is having 1220 observations of two variables. See here. So in this data set, you're having adults, and if you drag down, adults and children's is in your first column. Adults or children's. And in your second column, it is, I just mentioned it as ice cream. Did not purchase, purchase. Like this, you're having whether the particular children purchased or not purchased, whether a particular adult purchased or not purchased. Like this, you're having your data set. Adults did not purchase, adults purchase, like this. So using this data, I need to build my two proportion test. Two proportion test. So I've changed the variable name to a variable called as CPG. CPG. I'm going to attach this CPG. Attach CPG. Now, so now let me ask you a question. If I run this, what will be your output? I want you all to ping your answers on chat window. Personal chat. Don't tell your answers. Ping me your answers on private chat. If I run this line of code, line number 58, whatever I've written now, what will be your answer? Just ping me your answers on private chat. Answer. Okay. Most of them are giving it as 2 cross 1220, 2440. Devanshu, it is wrong. Neha, it is wrong. S. Kumar, it is wrong. Bharat, it is correct. Bharat, you're just telling the, okay, fine, that is also correct. Yes, Ranjini, it is correct. How about others? Rakesh, Manjunath, Rahul, Ratnesh. It will give you output of CPG variable double values? No. Bhupendra, please go through the videos once again. So it will give you the dimension. Dimension in the sense, it will give you Ratnesh correct and one more person, Bharat, Manjunath. So Manjunath and Neha, S. Kumar, some of them are wrong because you are telling it as columns versus rows. It is always rows comma columns. So it should be 1220 by 2. It is not 2220. You are just interchanging your answers. That is your rows and columns. You are interchanging it. It should be, see here, 1220 and 2. Here also it is 1220 and 2. So this is your rows and columns. Your answer is correct, Bharat. Your answer is correct. Now, so what it will display? Now, come on. So if I run this line of code, this part, what it will display is my question. Give a try, or else I'll write it like this. This line number 60, what will be the output? Just give a thought. Even though if it is wrong, not a problem, just give a thought. Table of person. Table of person is nothing but, you're having a column called as person. So table of person, what it will give you? Person column values? No. How about others? Person column values, Lahari? No. Person column values in the sense you mean to say that particular column values? No. Adult and children? Yes. It will display how many adults and how many children are there out of 1220, 600 and 620, like this. Yes, it is like this. Total 1220. How many adults are there? How many children are there? It is going to give that. So let me try to So just try to reconnect Bharat once again. Can somebody ping Bharat and tell him that just try to reconnect? So table of person. So you can say that it is adults are 480, children's are 740. So if you use this table, it is going to give you in that particular column how many categories are there, and out of how many categories, how many records are there with respect to that particular category. We are having only two categories here, adults and children's, and out of 1220 observations, 740 are your children's and 480 are your adults. So if you add these two, it will become 1220 records. 1220 records. Now, what about this line? Line number 59. So if I run this, I am going to get like this. I'm going to get like this. So ice cream, adults, children's, ice cream, purchased, not purchased. How many of them adults purchased? How many of them children's purchased? How many adults did not purchase? How many children did not purchase? You are going to get in that way. So I'm writing table with respect to both the columns. I'm writing with respect to both the columns and storing it in a variable called as table 1. So if I just run this table 1 now, you'll be able to see your output. See here. So ice cream did not purchase, purchased. Under person, how many records are there? Adults and children. So adults, how many of them purchased? Only 58 purchased. Children's 152 purchased. Out of 422 did not purchase in adults and 588 children did not purchase. So your table function gives you the number of counts of each and every category in your data. Write down this table in your own words. Write down this example also. Yes, it's similar to that only, Ratnesh. I think it's raining in Bangalore because most of the internet connections are slow today. I think that's the reason most of them are reconnecting.
Yogesh, I think the table function gives that data set in the tabular format, right?
Yes, not only that. See, not the tabular format. See, if I just run only one column, yes, I'm going to repeat it. See, simple as I'm going to give you like this. So there it is adults, here it is children's, not like this. Person, okay. Here it is ice cream purchased, purchased, not purchased, not purchased, purchased. Okay. Now here it is adult, children's, adults, children's, adults. So now based on these records, how many adults are there in this whatever I've written? 1, 2, 3. Okay. And how many of them purchased? And out of adults, 3 adults, how many of them purchased? How many of them did not purchase in adults?
2, 1.
2 purchased. Adults, 2 purchased. Adults, 1 not purchased. Purchased is 2 and not purchased is 1. And out of
Yeah,
children, how many children are there?
2.
Yes. Out of 2 children, how many of them purchased? How many of them not purchased? That will be displayed in your tabular format. Is that correct, Bala? What is your answer? Same, right?
Yeah, same.
Yes, it is same. But if you use only single column, it will give you like this, adults and children's. Got it, Bhupendra, Debanshu? Okay, fine. So now I'm going to implement a test called as proportion to proportion test. Yes, Bhupendra. So proportion dot test is prop dot test. Here I'm going to pass my x parameter and y parameter. X and y parameter you should pass it. It is not like x and y, you can give it as anything, but I'm giving it as x and y. X and y. So now Now, prop.test is a function. Prop.test is a function. And what is this and what is this? Can you tell me what is this and what is this? What do you mean by range 58 to 152? Bhupendra, please
Purchase,
don't.
purchase, not
Yes.
purchase.
Yes, this is your purchased. See, 58 adults purchased, children's purchased. Okay. And what about this? That is my question. This one.
Total count of the adults
Yes,
and
it is your
child.
total count of your adults and children. Because if you want to calculate your percentage, whatever you have scored, you are going to take, right? So out of 100 marks exam, so the total is 100. If you have scored 55, you are going to take 55 by 100. Like this, you are going to calculate your percentage. Similarly, here also I'm taking with respect to my X, and I'm passing it as X and not purchased. This is your total number of records. N is total number of records. I am passing it as this. 58 and 152 is purchased, not purchased with respect to adults, purchased with respect to children's. And here total number of counts with respect to adults, total in the sense these two, 422 plus 58 is 480 and 740 is nothing but 588 plus 152. Total of this is adults total, children's total. If you pass this and if you run this algorithm called as prop.test function, you're going to get your answer, p value. So here you can see that what is your p value?
100.
Yes, this is 0.000001. Is it greater than or lesser than is my question.
Less than.
So this is your less than 0.05, less than 0.05. So P low, null,
Null.
go.
Null go.
Means we should accept null hypothesis or alternate hypothesis. That is my next question.
Alternate.
Yes, null go means null is going out. I'm going to accept my alternate hypothesis. So what is your alternate hypothesis? Just now we wrote before your implementation.
Not equal.
Adult
Yeah,
purchase.
adults purchase is not equal to children's purchase. So what is next?
We need to check the adults not purchase.
Means who has purchased more, right? Next you need to purchase. You need to check whether adults purchase more or children's purchase more. You need to check it out. So for that, what will be our next null hypothesis and alternate hypothesis? So what is your next null hypothesis?
Not purchase.
Children will purchase will be H0.
Yes, see, Ratnesh, you'll not be getting exactly 0.05. If you get it as exactly like this, go for null hypothesis. If you get exactly like this, go for null hypothesis. If you're getting lesser than this, P low. I'm not telling it as equal to. So that is the reason. Go for alternate hypothesis. So for this, what will be your case study? What will be your null and alternate for this? Tell me. Come on.
So who has purchased more? Whether adult has purchased more or
No.
children has
Yes,
purchased
but
more?
you should tell me what will be your null and alternate. Null should be adults purchase is less than or equal to children's purchase. I told you, right? Null hypothesis should be always with respect to your less than symbol and equal to. And alternate should be
correct.
adults purchase is greater than children's purchase. So stick to this thumb rule and you can write down this. For next step, adults purchase is less than or equal to children's purchase is your null hypothesis, and alternate is adults purchase is greater than children's purchase. Lahari and Bharat, please be on mute. Rakesh, are you there today? Okay. Rakesh is there. Fine, Rakesh. Okay, next. The next step, I'm going to check whether it is equal to or not equal to. Equal to or not equal to. Now, here, coming to this line of code. So as I've told that your null hypothesis is less than or equal to, and alternate hypothesis is greater than or equal to. So let me just drag down this towards right hand side. So here I'm going to write same thing, proportion.test, prop.test, same as it is. 58 and 152 is your adults purchased, children's purchased. This is your total adults, total children's. Alternative, one more extra parameter I'm adding. Earlier, as it was two-sided, I did not add it because you're checking for equal to, not equal to both. That will be default when you use your prop.test. As of now, you're checking with respect to less than or equal to or greater than. So I'm specifying it as alternative is greater. Alternative is equal to greater. So if I run this, I'm going to get your p-value. So what is your p-value we got just now? 0.999. Is it greater than 0.05 or less than 0.05? P is
Great.
value is greater
Greater
than
than
0.05. So which one you should accept?
alternate hypothesis.
Read once again.
Not equal
P high
to.
null fly. P high null fly Lahari. Devanshu. Is it P high null fly or P low null go? Read once again. It is null. Null
Null
hypothesis.
hypothesis.
Lahari. Yes. What is
Yeah.
your null hypothesis just now we wrote?
Adult purchase is lesser than children purchase.
Adults purchase is less than or equal to children's purchase. Children's purchase. So consider this is Lahari and this is Mega. So Lahari purchases is lesser than or equal to Mega's purchase. So so your adults and your children's purchase. By seeing your comment, so what will be your decision? Please be on mute. Upendra, please be on mute. What will be your final comment on your this thing statement? What are you going to tell to your manager?
You can go for incentive program.
You'll go for incentive program or you'll not go? Bala.
No, we'll not go for incentive program because
Yes,
that
you will not go because sales
95
executives
greater
already
than,
said that yes, adults will not purchase and children's will purchase. So here it is also same because we have proved that adults are not purchasing greater than your children's purchase. So that's the reason we should not go for sales incentive program. So based on your statement, based on your sales executives comments, so you are also proved that adults are not purchasing more and children's are purchasing more. That's the reason you should not go for incentives.
incentive.
So write down the statements. Write down this particular statement with respect to this case study. Then we'll move on to the next case study. So I'm going to go for the next slide. Please understand the business objective, that is your chi-square test, and tell me what is the business objective for this chi-square test. Can somebody explain what is the business objective?
Yogesh, the screen is not changed. The slide.
One sec. Let me refresh. Now, to proportion. Oh, sorry. Let me just read this. So can somebody tell me explain this case study?
Yogesh, I'll try.
Yeah.
There is a company where they have recruited 4 data entry operators, employees, to enter the data into the system,
Okay.
and they need to check the accuracy of the each four persons
Mm-hmm.
with respect to the questionnaire response and what the data they are entering in.
Yes.
And they need to, the last point I didn't get, that 5% significance level.
Okay, I'll explain that.
Yeah.
So coming to your XYZ company. So there is a company called as XYZ, uses 4 data entry operators. These 4 data entry operators, I'm choosing it as from different countries. 4 different countries data entry operator. One is from India, another one is from China, Sri Lanka, and Bangladesh. These are the 4 different data entry operators to input the data of questionnaire responses. So these data entry operators has to enter the data into the system, and this data is nothing but survey data. Questionnaire responses means survey data. Survey data. Any error, so this one, they audit a certain percentage of the survey data, that is your questionnaire responses, versus data entry. So they cannot do survey of all the data entry with respect to all the survey questions. They have taken some 25% or 30% of the questions, and they have checked how much they have entered correctly and how much they have done wrong entry with respect to your data entry. Any error in your data entry with respect to these 4 data entry operators, if they have done any error, that means it is defective. The chief data scientist of this company wants to check whether the defective percentage across all these 4 data entry operators are same or different. So you need to check it out. Analyze the data at 5% significance level. This point, you did not get this point, so it is nothing but analyze the data at 95% confidence level. If you are telling it as 5% significance level, it means that you should be 95% confidence level. So in some questions they might directly give it as 95% confidence level, or in some questions they might give you 5% significance level. So if they give you 15% significance level, what does it mean? If they give you as 15% significance level, you should be 85% confident. So that is the reason I have mentioned it as 5% significance level, and help your chief data scientist, that is your manager, to draw an appropriate inference about this survey or this particular case study. So 1 means here it is not defective, 0 means it is defective. 0 means defective, 1 means not defective. So now my next question is, what is your X, what is your Y? You should identify this.
X is operators, 4 operators.
X is 4 operators. Yes, that is nothing but your Indian operator, China operator, Sri Lanka operator, and Bangladesh operator. A data entry operator 1, D2, D3, D4. Now what about your Y output?
Data that
Yes,
they are
output
entering.
is this one, defective or not defective?
Defective.
One or
Or not.
okay. Now, what is your null hypothesis and alternate hypothesis for this case study?
Uh, 95% confidence, then it will be less than equal to.
No. First, you should not go with respect to that one. What is null hypothesis and alternate hypothesis?
Data that the 4 operators are
Defective.
entering are without error.
Same.
Yes. So data entry operators, defects across all the operators are equal.
0.
Defective or not defective is your output. So
Okay.
defective across all the operators data of all the 4 operators are equal. That is your null hypothesis. And here, what is the alternate hypothesis?
Not equal.
Not equal. So it is directly not equal. You should tell it as at least one data
not
entry
equal.
operators. Yes, because it can be like this: d equal to d1 equal to d2 equal to d3 is not equal to d4. So that is the reason you should tell it as at least one data entry operators defective is not equal. Defects are not equal. Write down this step. What is your x? What is your y? Write down this, and along with your case study, write down everything. I'm going to give you 2 to 3 minutes. Is it done? So now I'm going to my RStudio. And let me go and implement your chi-square test. Chi-square test. So I'm going to use data entry. Like this, I'm going to give DE. So I'm going to clear this older files, everything. So now I'm going to read an Excel file from my local system by using read_Excel function and store it in a variable called as DE. DE. So this is your chi-square test data. This is your chi-square test data. So let me go to your RStudio and see. See, what is the dimension of this data? It is 800 records and 2 columns. 800 records and 2 columns. So now you can see that country-wise your data entry operators are mentioned. Country-wise your data entry operators are there here. So out of 4 countries, data entry operators, data entry 1 is India, data entry 2 is, let me just check it out what it is. So 200 like this. China is from 201. See, from 201 it will be China. From 201 it will be China until 400. Until 400 it will be China, and after 401 it will be some other country, Sri Lanka. You can see the Sri Lanka from 401. and then it will be Bangladesh. From 601 it will be Bangladesh. Yes, it is your Bangladesh. So for different countries data entry operators data is there, and this column says you that it is either defective or not defective. Defective or not defective, you should check whether they are defective percentage across all these 4 data entries operators are equal or not. So I'm going to attach my file called as DE. So now if I run this line of code, what will be your answer? Come on, tell me. I'm going to remove this.
Each country total will come.
Yes. Count of all countries. Yes. Out of
Yeah.
all the countries, how many counts you are having? 200 Bangladesh, 200 China, 200 India, 200 Sri Lanka. So yes, we got it with respect to that. Now, if I run this line of code, class of Bahman, what it will give you? Class of D. Instead of Bahman, I'm going to change it to D. So what it will give? Class of D. Input for all the countries. No, I'm talking about class. I'm talking about your class, that is your data.frame. Data.frame will give you, it is a type of your tabular format. So in this X, it is storing a variable with respect to your country wise, how many zeros and how many ones are there. Country wise, how many zeros and how many ones are there. If I run this X now, I'm going to run this X. See. Table country versus defective. Country is on your Bangladesh, China, India, and Sri Lanka. In your defective column, it was 0 and 1. So Bangladesh is having 183 zeros, that is defective, and non-defective 17 is 1. China like this. China like this. Actually, we can identify in this step only. If you take this, you can identify here itself because both of them are not same. Both of them are not same. But when do we go for two chi-square tested? When you are having this type of case studies, you go for chi-square test. So that is the reason I'm showing you this particular case study. And if you see this, there is a function called as chi-square.test. CHISQ.test is a function, and if you pass this, that's it. If you pass this, you're going to get your answer. Nothing else. Yes. See, class function will never give you anything. It will give you what type of data you are having, what type of data it is. So it will give you that it is in your tabular format. Tabular format, Neha. Because in your, it will not tell it as table. In your R programming, it is called as data frame. It is called as data frame. If your data is in the form of rows and columns, and it is called as your tabular format, and that is called as your data.frame. Got it, Neha? Okay. Now, so you are just passing this chi-square.test, CHISQ.test function, and you should pass this parameter. That's it. That is nothing but you are using this. Or else, let me just try to pass your variable called as X. Because I've written it as X, I'm going to save it as, pass it as XC. If I pass this chi-square dot, because I've written this function and stored it in a variable called as X. So that is the reason I can pass directly this, or you can pass directly like this. It will be one and the same. It will be one and the same. So what is your p-value here?
6315.
0.6315. But if you have not performed your chi-square test, by seeing just the data part, the number of count, you could have misguided it. Means it is misguiding you, because it is saying that 17, 21 and 79 and 75, 25. By seeing this count, you cannot come to conclusion. By seeing this count, if you were suppose coming to conclusion that all of them are not same, then your answer would have been wrong. So your statistical thought or your statistical analysis says that your p-value is greater than 0.05, that is 0.63 is greater than 0.05, p high null fly. So p high null fly. So based on this, you can tell that your proportions are not same. Proportions are same. Proportions are same.
Sorry, Yogesh, the proportion
Yes.
are same or not same?
Here it is same. See, if you see this, you're see, it is just something like in your data only. You're just counting how many zeros are there for Bangladesh, how many zeros are there for India, how many zeros are there for China, how many zeros are there for Sri Lanka, and how many ones are there for all the countries. But if you see this, it is just a basic check what you can do it in using your Excel itself. Then what is the need of going for chi-square test? So if you want to prove it statistically, you should go for chi-square test, or it is your, with respect to your statistical analysis, you're going for chi-square test. Chi-square test. In this, it says that it is what? P-value is how much?
Greater than 0.05.
Greater than 0.05. P high null
Null fly.
fly.
Null fly.
P high null fly. So P high null fly means it is your all the proportion defective across all the countries are equal. Means it is not talking with respect to number of zeros and ones. It will take you the proportion of the defects. Proportion of the defects. And this is, I've written it for something else. I'm going to remove this. Not going to remove, I'll just comment it. Yes. So you can use this CHISQ.test function, and you can pass the total data set of your table versus country versus defective. And here, if you use it, you're going to get your p-value, Pearson's chi-square test with respect to your p-value. Your p-value is greater than 0.63. So your p-value is greater than 0.05. It indicates that proportion of your defects across all the 4 data entry operators would be same. So the function here is called as CHISQ.test. This is my dummy data sets. I have prepared it on my own. So whenever you get such type of cases, you should go for chi-square test. For chi-square, it is CHISQ.test. That's the function.
If it comes less than 0.05, it go for alternate.
Yes, obvious it is.
Yogesh, I have one
Yes.
doubt.
Yes.
In real time, like any of the case studies we would be given, and for that thing, we need to write this H0 and HA for that particular case,
Case
like
study.
that
Yes.
is for our reference, right?
It is for your
Like
reference.
before.
For example, for example, you get Monday morning, you go to office, your project manager says you that we have got a new project. So I'll give you some initial decks, whatever the client has shared. Please go through this and come back with your hypothesis. They might give you like this. If you are senior data scientist, they might tell you this. Suppose if you're junior data scientist, your senior data scientist or your team leads or your project leads might take this and they might do some analysis, like what has to be done. Has to be
Okay.
done.
So data science work. Okay. So all the work will be comes in in this case study only. All the project
Yes.
work will be.
Yes. See, this is just an
Then
initial
you
hypothesis.
initially.
Like after framing this, it would be easier to write the code in R, right?
Yes. See, it is either R or Python. You can do it. It's up to you. But majority of the time, for initial hypothesis, first when you start your projects, you will not be involved probably, or sometimes you might be involved. Probably your senior managers or senior data scientists or your senior data analyst person would take this part.
Okay.
So I'm going to show you one R Markdown. Please concentrate. What is so it is R Markdown is nothing but instead of writing it in your R Studio, you'll be saving it as .rmd extension. If you save it as .rmd extension, that is called as R Markdown. R Markdown. If you use this, you can also document. You can also document whatever you are writing, each and everything, and also you can publish it publicly. You can publicly publish whatever the code you are writing. So I'll just show you that part as today's session. So let me close this and let me open a new window. Concentrate here how to do this. From first I'm going to explain this. R Markdown is a new concept from your R this thing. It is used for documentation and also publishing it publicly. Like your Jupyter notebook, you can write it. So first click on this file button. Don't click on this R Markdown. Either you can click on R Markdown and you can go, or else directly click on text file. So I'll be showing with respect to text file. You can choose like this. Click on text file. So here you can type your programs. For example, consider that I want to do your basics of statistics. Basics like 1 plus 1 equal to 1, 2 plus 2, 2 minus 2, all those things. So I'm going to write it like this. Concentrate. Hash symbol. I'm going to write it. This is something like if you use single hash, it is something like your heading. It is something like your heading. So I'm going to write it as basics of statistics, stats. Basics of stats. Basics of stats. In your second line, I'm going to give it as sub headline. In your second line, I'm going to write it as today's date. For example, August 27, 2018. I'm going to write under that again smaller headline like 7:30 p.m. data science batch. Okay, now I'm going to save it. See here, I'm going to save it as .rmd extension. .rmd extension, I'm going to save it. I'm going to give a name as basic.rmd. Remember, I'm giving it as an extension as rmd. See, once I save it, everything turned into blue color. Everything turned into blue color. Now I'm going to write my original program or original code here. So before writing your original code, you should use these three symbols, and these three symbols are below your escape button. Below your escape button, that is a tilde operator is there, right? Without using shift column, type 3 times and open and close your square flower parenthesis, flower braces, and write it as R. Write it as R and go write it as 1 plus 2, 1 minus 2, 2 into 3, 2 divided by 3. Whatever the programs you want, you can write it here. You can write it inside this. Whatever I've written it inside this, right? So you should use this and you can write it. Now, I'm going to write something called as probability of normal distribution, or I'll write it as QNorm. QNorm of 0.975. So 0.975 is what? What is the answer for this? If I run this, QNorm of 0.975, what is the answer for this? .96. Okay, so let me show that. So I have written something like this, and I'm going to write close this. I'm going to close this chunk. Same three symbols you should write it for closing this particular chunk. And now I've saved it. Now I've saved it. Now you can pass this. Now if you just click on this, see here, output has been executed. See, If I just click on this button, it will run. So this single block is called as your single check. Whatever you're writing within this particular three symbols, that is your code symbols and R with respect to your this is your one chunk. So I can write this chunk below one chunk. I can write again. Next chunk also I can write it as A equal to 1, B equal to 2, C equal to A plus B. I'm going to write it as A, B, C. And here I need to give it as R because I'm writing it as R program, R markdown. So here I'm going to close. Second check. So I've saved this. Again, if I click on this, I'm going to execute this particular chunk. That is one block. This is one block. Here the blocks are called as your chunks, small chunks. See, this is one chunk, and this above one is called as another chunk. Got it? So if you want to write any program, whatever we have written till date, you can write using this. Going to this, you can click on text file and you can use this symbol and this R and you can write it. You can write it. Your output will also be displayed below this chunk only. If you want, you can see and you can close it. It's below this. Or you want to see in your console, you can see here also. You can see here also. I'm going to run this. See, A equal to 1, B equal to 2, C equal to A plus B. A is 1, B is 2, C is 3. Now you can save it or you can publish it. See here, there is a button called as knit, K-N-I-T. Click on this. Click on knit to HTML. If you click on this knit to HTML, it is running. See, until and unless this stops, see, it is starting. 33%, 67%, 100% is done. 100% is done, and it will open in your viewer window. See here, or you'll be able to open it in viewer window. See here. So whatever we have written, basics of statistics, I've used it as single hash symbol, which is bigger in heading. Below that, I've given it as 2 hash symbol sub headline as August 27, 2018, 7:30 p.m. data science batch. So this is my 3 hash. So, and I've written 1 plus 2, and that has created something like your Jupyter notebook. See, 1 plus 2, and below that you're getting it as 3, 1 minus 2, you're getting it as minus 1, 2 into 3 is 6, and 2 by 3 is 0.662 raised to the power of 3 is 8. Everything is been published here. So now, so after this, if you want, you can save it as knit to word. See, I'm just clicking it. Instead of clicking as knit to HTML, I'm clicking it as knit to word. If you click on knit to word, it is going to save it as a word file and it will open your word file. So 100% is done. It is preparing your word file. It is preparing your word output created basic.docx. It is still opening. It has not yet opened. See, until this red button stops, it is still executing. It is under process. It is creating your basic.docx file because I've written it as basic.rmd. Basic.rmd. See, it is creating. It is creating. Yes. See, it has created basic read-only document. It is opening automatically. See. Got it? If you want to write it, if you want, you can save it. File, save as, you can save it as whatever you want. Yes. Now, coming to your, apart from this, you can also publish it. Apart from this, you can also publish it publicly. Once you are doing this knit to HTML button, after that, it will show in your viewer window, or automatically it opens a external window. After that, you can see this symbol here. You can see this symbol here, and you can use that symbol to publish your document. So click on this, publish document. If you click on this, if you use this RPubs, see here, you can read this. RPubs is a free service from RStudio for sharing documents on the web pages. Don't use this because this is something like your RStudio Connect is a server product from RStudio. So this is if it is for RStudio, if you're having server, go for this RPubs. Before going to this, you should have an RPubs account. So just go to Google page and type it as rpubs.com. rpubs.com. Let me just show you that. Just go to rpubs.com. rpubs.com. You need to create an account. It is free of cost. You do not have to worry about anything. It is just a free of cost. rpubs.com. See here. Brought to you by RStudio. You can just click on register. First time you will need to register it, and then you can start signing in. Then you can go for starting signing in. Now, as I've already am having an account, I'm going to click on this, and I'm going to select this RPubs. See, I'm going to click on publish. I'm going to click on publish. SSL certificate problem, self-signed certificate in certificate chain. So actually I'm using my office system, so that's the reason I'm getting an error. So you can use it. Probably you will be able to publish it. See, it is opening. See, you can give your name. For example, today's date I'm going to give August 27, 2018. I'm going to give, and if you want to write anything, you can write it as like basic stat or RMD test. I'm going to write it as RMD test, and you can give your anything. Just give it as test name. Continue. Whatever the name you want, you can give it here. Continue. So it is preparing your document. Then it will display whatever we have typed similar to your Jupyter notebook. See. A equal to 1, B equal to 2, A is 1, B is 2, C is 3, everything is being displayed. So this is how you can publish it on your rpubs.com for free of cost. And now if you want to share, you can click on the share button, and you can just copy that link and you can share it for anyone. You can just share it for, you'll be able to share that, copy that particular path, and you can share.
So it's like how we publish the dashboards in case of Tableau publicly.
Yes, like your Tableau reader or your Tableau desktop, you're going to prepare a dashboard and you can just publish it, right? It is similar to that.
Okay.
Actually, I've already published many of the documents here. So that's the reason I'm able to see multiple answers here. Because if you go to this, see, if you go to my this thing rpubs.com yogesh84, I've just publicly posted. See, just now we posted, right, RMD test 2 minutes ago. It is showing the time, and yesterday I published this. Day like 23 days back I published this. like about 1 month ago I published this, 1 month ago I published this, same like this. So whatever I published, everything is being stored. So you can just go through this, copy this, and if you go and paste it anywhere, you'll be able to access my publishing. If you want to choose anything, you can choose.
Yogesh, I think it's a dynamic, right? It will work as a dynamic. Suppose my source data get changed, automatically whatever we publish, right? I mean,
Yeah.
they refresh that, automatically it will get changed.
You mean to say here, if I change it?
No, from suppose now my data is changed actually. Today my data is something different, which contains only
Okay. For example,
July
here,
data.
Bala.
Yeah.
Yeah, see here, Bala. I'm going to add something. For example, D is equal to A divided by B. Okay.
Yeah.
E is equal to A into B. Okay. Now I'm saving it. I've saved it.
Yeah.
Now, do you think it will be updated here?
No.
No. It will never be updated dynamically until and unless you publish it.
Publish. Okay.
You should publish it.
Okay.
So that is the reason you should go for need to HTML. Then after this, you can just click on this and you can publish.
Yeah. Got it.
Got it? See,
Yes.
it is only C. We have created D and E. That is not displayed. Okay, so this is about your R Markdown. So if you are using hash symbol, it will be something like your heading, subheading. If you are using single hash, it is heading, subheading. You can put it as title like this. So I'm not opening this. I'm just closing this. So this is what is your R Markdown does. So from tomorrow onwards, we are going to start a new topic called as correlation analysis. From tomorrow onwards, we'll be starting a very important topic, correlation analysis. Probably in 1 or 2 days, we'll build your first prediction model. Probably tomorrow or day after tomorrow, we'll try to build it. 90% we'll try to build one model tomorrow. It depends on your understanding. Okay.
Yogesh,
yeah.
This hypothesis testing is also showing in the Python also.
See, this hypothesis testing I'm not showing it on Python. I will be showing it in only in R. And apart from that, everything will be shown in both. Which is important. More important, I'll be showing it in R. Both R and Python. Actually, this hypothesis testing, I've included it as a part of your curriculum. Earlier, it was not like we were not teaching this. I just added it as a bonus part. And also, I've added one more topic. I'll update you what are the topics I'm updating regularly. Okay, so tomorrow again same time we are going to connect around 7:30 p.m. So make sure that you connect by 7:30. If you are doing 5 minutes late, again we'll be 5 minutes late. That's the reason. Okay, tomorrow onwards we'll be starting with correlation.
Yogesh, I have one doubt actually.
Yes.
Regarding the Z table.
Yeah.
I'm looking for the T table.
Yeah.
There is just let me open. Because the percentage here, no, the 92, 90 and 95 only is there.
Yes.
And population also is after 100 only the 1000 is there.
Yes. That is not population. That is your degrees of freedom.
These are degrees of freedom. Suppose
yes.
if something coming as a 12,000 or 9,000, so it will be between 100 and 10,000, 100 and 1,000.
See, obviously, if you are getting a degrees of freedom as more than 1,000 anything, you should go for that 1,000 degrees of freedom value. That's it. If it is anything below 500, you should go for 100. If it is anything above 500, you can go for 1000.
Even
Because
what are
it
the
is like,
percentage?
yeah,
Even the
percentage
percentage also. Okay. Because the assignment which you given, we are getting more than 1000 some of things.
Yeah, that is
So
what
we don't
that is
have.
the reason. That is the reason I
Okay.
told you in the last session itself. You should go for the nearest value.
Okay. No problem.
Nearest value. Okay. So thank you all. Good night. We'll connect again same time tomorrow at 7:30.
Okay. Thank you.
Thanks. Bye. Because it is raining, Devanshu.
You guys can also send me the program and the data sets.
Sure. I'll be sending it. Yes, Devanshu, I'll be doing that. Okay. Thank you all. Good night.